One of the main goals of Scineric Workspace is to help you to manage build configurations for a set of files. A build configuration depends on the context of what the files represent. Like for example, in the software design, this will represent the tool chain to help you run make in the background and the software compiler. In the firmware design context, this will typically be a set of commands that needs to be executed to compile your VHDL files for the vendor tool chip that you are targeting. What I'm going to do is I'm going to start off with an example design and show you how to add build configurations to it. In your design widget, you can go to the builds tab just to view the build configurations in your design. At present there is nothing. To add new build configurations, you can click on the add new button. The add new button will give us a drop down menu where you can select from numerous different options on how you want to add new build configurations. The first one is saved custom configurations, which is basically a list of custom configurations that you can create and reuse between different designs, or it can be a build configuration that a different team member made and you're reusing that. The next one is templates. Templates are ready to use build configurations provided by the plugins that is currently loaded in Scineric. You will notice that over here we have some specific configurations for vendor tools. At the moment we have a Xilinx and Altera plugin configuration, plugin loaded, so these build configurations comes from those plugins. We also have a Plunify plugin loaded, so you will notice a couple of Plunify build configurations. The last one is a configuration template, which is a generic empty build configuration that you can populate manually. The last option in the drop down menu is import, which allows you to import the build configuration from different sources. At present you can import the build configuration from a Xilinx ISE project, or you can load a Scineric Workspace build configuration file that somebody else has sent to you. For this demonstration I'm going to focus on the firmware vendor tool build flows. So if you click on the Xilinx ISE flow, it will add the Xilinx ISE build configuration. Notice when you add it, it will select it and it will show you a widget with the details of your build configuration. So Scineric Workspace groups build steps into 3 different categories. Namely, the first one is preparation, then the second one is the actual build process, and then the finalization process afterwards. If you look in detail, you will notice that the top part of this widget has some generic or very specific settings for this specific configuration. So the first one is a target device, which is specifically for a Xilinx target device. If you click on any of these items details area on the right, it will expand with some details below it. So let's click on the target device details. You will notice it will expand a widget that has drop down boxes for you to select a Xilinx device. Notice that there's also frequently used parts details area that we can expand, and we will see a list of commonly used devices in our team. These team devices are all stored in the team settings file that you can share between your team members, so that you don't have to go and ask somebody else what exactly the devices they are working on. You can get it from this frequently used parts list. So we can select any of these items and it will update the device that's going to be used for this build. I'm going to close this. Another thing to notice here is the ISE environment. Scineric Workspace allows you to set up multiple environments for vendor tools. That includes Xilinx, Altera and Plunify, and all of these drop down boxes where you can select the environment will reference the ones you've set up. For example, in this one we have ISE 13.1 and ISE 14.1 set up. When you select another one, you will notice that a task ran, which basically runs the settings bat file that Xilinx provides in the background. So when you switch your environment in here, it will set up your system to use that ISE version. I'm not going to go through all of the details of all of these detailed steps. What I want to show is the configuration properties, which has a bunch of macros that you can use in your build steps, and when you run your build step they will be expanded to these values. The target path shows you where the build will be run. Now this is determined by your file association database, or you can customize it if you don't want to use the value specified by the file association database. It is however recommended to use that value because these databases have a structure that they allow you to use without thinking about it. But you can customize that or create your own database. Lastly, I'm going to go to messages. So if you click the refresh button on your build configuration, it will refresh. If there was no errors or warnings in your build configuration, messages will close and it will tell you there's none. If there was any errors, it would give you the details. For example, if there's a file that's part of your design that does not exist, it will give a warning, and you can choose to ignore this warning or to act upon the warning. Next up, I'm going to go through build step. A build step is a single backend process that's going to be executed. It all happens in sequence. So for this example, it will start with clean design, next will be generate cores, next synthesis, etc. until you get the process generated files. If you expand a build step, you will see properties for that build step. For example, for clean design, we have a few things that we can specify. Also for generate cores, etc. All of these has specific properties to the build step. You will notice that the Scineric ISE flow is fully integrated, meaning you can see all the properties for the Scineric's backend tools directly in Scineric. When you change the value of a property, you will notice that the value or the text of the property becomes bold, meaning that it's not the default anymore. So for now, we've unselected match version generic, and you can see that it's bold. You can also move steps up and down. So if we close the details, you can click on this down button and you will see the synthesis moves down. So you can easily reorganize the order of the steps in your design. You can also disable steps by clicking on the far right button. So if you want to disable steps in a specific run, you can do it like that. Lastly, you see the settings button on the left. So if you click on that, it allows you to view advanced settings for a step, or to disable steps before, after it, and some other details that's not shown at present. It's only shown when you run it. So if you're familiar with the Scineric ISE flow, you will notice all of these steps, and then you will see after finalization there's a Scineric specific step which is called process generated files. So the way of the methodology behind the way Scineric Workspace handles the build configuration is it will start at the top, it will clean your design, and it will regenerate a new build. So you have a build working directory where it will actually do the actual work. That's the target path of your configuration, and when you're done, it will actually process the generated files and copy the ones that you are interested in to your results area in your working directory. That means you can have multiple builds running and you can have one set of results. Now there's lots of options over here and customization that you can do, but that you can explore on your own. Last thing I want to show over here is that you can add new steps. So if you click on the add preparation step or add build step or add finalization step, you will get a list of specific steps that you can add. So let's add, for example, the custom build step, which is a custom backend process that you can run. So you can run your own command and give it additional arguments, and you can set the working directory. Something to note here is that you can specify macros from your configuration properties, or you can also use macros that refer to system environment variables. Those environment variables will be expanded when you run your build configuration. Next up, I want to show if you add another configuration, how you can compare them. Important to notice, or a very powerful feature, is that you can have multiple configurations per design. So we can add as many as we want. Let's add Altera Quartus flow, for example. Notice that we have the Quartus compile step, the clean, and the process generated files. Again, we have a specific area to select our device and so on for this Quartus flow. We can also add, for example, a Plunify flow. Let's add another one. And there you can see you can have multiple configurations. The one with the check mark next to it will be the active one. So that's automatically chosen when you choose to run your design. What I want to show next is I'm going to select this ISE flow configuration, and on the top right you will notice more options. The more options allows you to perform multiple options on the specific build configuration. So you can restore it to its default state, you can clone it, you can clear it, You can save it to a file to send to somebody else. You can load it from a file, and you can also see if this build configuration goes out of its updated state. Thus, you ran it and it was successful, and something changed and it becomes outdated. You can also see details of what triggered that. What I'm going to do for this demo is I'm going to clone this one. When I clone it, I'm going to select I want to add it to this design. Notice that now we have the Xilinx ISE flow and a copy of it. So what I want to show is how you can easily compare build configurations. To do that, you select multiple configurations in this list. So let's select these two, and you will notice that it will give us an overview. For both of them, it will give you on the left, for the first one you selected, it will give you all of those properties, and the right, the properties of the second one you selected. What you see here, for example, is that the target path is different for both of them. This is expected because the target path includes the name of your build configuration. Next up, you will see build steps. If they're the same, you will just see a list of the steps, and if there were differences, you would have seen the differences, a list of differences. Last thing you will see is build step properties. Now, if a build configuration has exactly the same steps as another one that you compared with, you can see the exact differences between build steps. Because it's a clone, you will see there's no differences. So what I'm going to do is I'm going to go back to the build step and change some properties. So let's change some in translate. Let's go to place and route, change more over here. Okay. Now we can go back, select both of them again, and you will see the exact differences between build steps at the bottom. So you will see in place and route all the changes that we've made, and then also in translate. This is quite powerful because it allows you to see quickly the differences between the build configurations that you run with. Okay. Now the next thing is to run one of these examples, or one of these build configurations. So I'm going to make the Xilinx ISE flow the default or the active one, and then let's just save this design. So we can go to File, Design, Save Design to make sure all of these configurations are saved to the design file. And let's go back to Files. So in the top you will see a play button. If you click on the play button, it will bring up the Run Build configuration or the Run Build area. Notice that you have multiple available configurations that you can run, and the one that was active is currently selected. For this demonstration, I'm going to disable a bunch of steps. I'm just going to do a synthesis run on this design, and now I'm ready to go. So let's click run. Now what you can do is we're going to run all steps. If you've run it already, you have more options if stuff becomes outdated and so on. So let's click on run all steps. Notice now that the design switches to the folders view, and it will show you the directory where the build configuration is run at the moment. So as this build spits out things, you will see it appearing in front of you over here. While it's running, you will see a log at the bottom, which is the messages from the different background processes, also warnings and errors. Here you can see it starts now, so you can see the files that's being spit out by those background processes. Another thing to mention while it's running is that the Xilinx ISE flow, for example, knows which properties apply to which devices. For example, if you choose a old Vertex device which doesn't have DSP48, those options won't be available in your synthesis tool or synthesis properties. It will be disabled and will give you appropriate message. Thus, everything that you will get in ISE in that level is also integrated into Scineric. Okay, you will notice that the build configuration ran through completely. Notice that the build steps becomes green and gives you an overview of the time that each build step took. Now, a build configuration, some build configurations allows you to view results in an external viewer. For the Xilinx build configuration, you can click on View Results, and that will call the Xilinx ISE Reports tool that will open for your directory or for the build you've just run. You can have all the capabilities of this tool in Scineric. I'm going to close that, and I'm going to go back to the Files view. When you're in the Files view, you'll notice that the outputs of your build was copied to your results area of your design. So if you look at this file, you will notice that it's in build results Xilinx. So that's defined again by your file association database. So you can change that if you want, but these files were copied, and you can see the results in your files view. It's important to notice here that the copy was made. So the original build that was performed still lies in the build area and the working area. This is just copies of the results. If you expand the process generated files build step, you will notice a few things. You will notice that we selected make copies of files, and we selected all files needs to be processed. If you are, for example, only interested in your bit file or your bin file, you can just specify the bin and bit file in there. Also notice that we've decided to append the version number to our file. I'm not going to go into the details of the version history in Scineric, but it's very powerful. It allows you to step, especially if you're testing a board or something like that, or building, you have 50 iterations. This allows you to easily keep track of version numbers. You don't ever have to type it in anywhere. You can set up top level generics in your top level design, and Scineric will automatically assign those generics to your current version. And you will also notice that your file names has those version in. So you rarely have to specify a version somewhere. Scineric takes care of that for you. And it gives you details of every version step, what happened in your version history. So if you change the property in, for example, map, and you step your version and run it again, you can see the differences, and you can see what properties changed to make those differences in your outputs. And that was an example, or that was a demonstration of the build configurations in Scineric. There's a lot more to this, and if you are interested to explore it, let us know. Thank you.